Good morning. I am Mrs. Saksali Jovita, Assistant Professor, KCS Kasinagar College of Arts and Science. In this video, we are going to discuss about linked list. The topics which we are going to cover are linked list and its representation, types of linked list, basic operation, and some application of linked list. Linked list. Linked list is also a linear data structure like our queue and stack, but it is not stored at a continuous memory location and which are connected through links, so that we named it as linked list. And why we need this linked list? And to overcome some limitations in array, we are going to use this linked list. The first limitation is the size of that array is fixed. So if we want to use that array data structure, we must know about the upper limit of the elements we are going to store. And inserting a new element in array is expensive because the room has to be created for the new element and to create existing element to shift. And deletion is also expensive. We need to have shift all the elements in forward move. So to overcome these limitations using array, we are moving to the linked list. Linked list representation. Linked list can be visualized as a chain of nodes where every node points to the next node. Here, list is represented by the pointer to the first node of the list. The first node is called head node. If the list is empty, then the value of the head node is null. And each node in the list consists at least two parts. One is data field and the another one is pointer field. It denotes the address of the next node. And one more thing, in the last node of the list, the next part of the last node will contain null value. That means this node is be the last node of the linked list. This is the representation of the linked list in memory. Types of linked list. So there are three types of linked list: simple linked list, double linked list, and circular linked list. Simple linked list. It is the most common list, and each node has data and a pointer to the next node, and the navigation of the items will be in forward direction. Double linked list. Here we add a pointer to the previous node in the double linked list. Thus, we can go in either direction, forward or backward direction, also possible. And the next one is circular linked list. Circular linked list is the variation of the linked list in which the last element is linked to the first element. This forms the circular loop. A circular linked list can be either single linked list or double linked list. For single linked list, next pointer of the last item points to the first item. In double linked list, previous pointer of the first item points to the last item as well. Basic operations on linked list: insertion, deletion, display, search, or some of the operations we can perform on linked list. Insertion adds an element to the list. So we can add to either the beginning, middle, or end of the linked list, as well as we can delete the element from beginning, middle, or end of the list. Display will completely shows all the elements in my list, and search operation will perform to find out the given element from the list. These are all some basic operations, and here we are going to discuss about the insertion operation. Insertion operation. In single linked list, the insertion operation can be performed in three ways: insertion at beginning of the list, insertion at end of the list, insertion at specific location in the list. First, we are going to discuss insertion at beginning of the list. So we can use four steps to insert the element in our list in front position, that is in beginning of my existing list. Okay, for that first we have to allocate memory for the new node and store the data in that node. This is our new node, and here we are allocating memory for that new node, and our first element is 10. This is the element we are going to insert in our list. And next, change the next of the new node to the point to head. So already our head node is holding this node as our first node. Now we want to insert our new node into this position. So we are changing our new node to point head. So this head will point this new node, and the head pointer is created now, and the next of my new node will point to the current head. Okay, just simply we are changing this. So before we do this, first thing we want to check that whether the list is empty or not. This is important. If my list is empty, then my head node is equal to null. As I already said, if the list is empty, head will be point to null. Here I am having two elements in my list. So as per example, my list is not empty. So if the list is not empty, set new node is equal to new nodes next is equal to null, and head is equal to new node. If it is not empty, then set new node next is equal to head, and head is equal to new node. This is how we are inserting at beginning of the list. Next, insertion at the end of the list. So we can perform this using the 6 steps. First, allocate the memory for the new node as usual, and store the data which we want to insert. And the third step we are going to do is we are going to traverse the complete list to find the last node, and we will change our pointers. This is the concept we are going to use to insert the element at the end of the list. As per the procedure, first create a new node. This is our new node which we created to insert at the element, insert at the list, and which holds the element 30. And for that I want to check if my list is empty or not. If my list is empty, then head is equal to null. That means there is no other elements in my list. The new node will be the first element and as well as the last element. Okay, if it is empty, then set this will be the head node, this will be the head node. If it is not empty, then define a node pointer, temporary node pointer. This will help to traverse through the list to find the current last node, so that we can insert at the last position the 30 element. So keep moving with temporary to its next node until it reaches the last node. So how will we will find the last node means, if any node contains the next part of that node as null, then it will be the last node. So till that we will traverse the temporary variable using the temporary variable in our list. So if we find the last node, and then we will change the next of the last node to the recently created node and fix that last node as our new last element. So this is how the insertion at the end of the list is performed. Next, insertion at specific location in the list. For that, we are going to repeat the first 3 steps as we previously done. Create a new node. Here, this is our new node which holds the element 50 which we are created, and check if the list is empty or not. If my list is empty, what will we do? The new node will be the head node and the first node. And if it is not empty, then define a temporary pointer. So this is my temporary pointer, and this will use to traverse the list from first node to the particular position where I want to insert the element. Here I want to insert the element at the third position, that is after the second node. So if my temporary node pointer should travel from first node to second node, this is the point where I want to change the pointers to the second node, from the second node to the new node. Okay, keep moving using that temperature. And before that, for that, every time we want to check if my temporary is reached to last node or not. In case if it has reached the last node, then display given node is not found in the list. So insertion not possible in between that node. So if it is my if it is my the first node is the last node, then I can't find the second node in my list. So we can display insertion is not possible. There is no other position as second node. But here we are having the second node and we are going to insert after the second node. So finally we are going to set our new node to the new node, or temp is equal to temp of new node, and temp of next node is equal to new node. So this is how we can insert our element in specific location in the list, and which is after the node. Here are some application of linked list. So as in previous class we discussed, stack and queue data structures can also implemented as represented as linked list, and we can implement the hash table, and we can implement the graphs in linked list. And the main important application is the polynomial representation using the linked list, and we are going to discuss about in the next class. And we also going to discuss about deletion operation about on the link and the polynomial application in detail. So thank you for watching.